What do you want?
I just need a TI Launchpad.
Can't you see I'm busy here?
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.
Hey everyone, welcome back to Make Live. I'm Tyler Weingartner, and this is the show where we build projects live right here in front of you, straight from the pages of Make Magazine. Today we're going to be building the Raspberry Pi Network Detective. This is a sort of network scanner that actively scans your network and reports out to a big display how many devices or computers or people that are actively connected to your network. And you might be wondering, looking at this, well, I have an app on my phone that does that. Well, you do, but this one displays it on these huge 6.5-inch 7-segment displays. So it's a really cool thing you can instantly glance at and take a look at and go, wait a second, there's not supposed to be 53 people connected to my network. It's normally more like 51. What's going on here? And joining me today via Skype, because he lives in England, is Alistair Allen, the gentleman who created this this project. So why don't we have a quick chat with him first? Alistair, how you doing?
Hey Tyler, not so bad. How are you?
Great. So why don't you tell us a little bit about how you came up with this project and why you built it and why you built it the way you did?
So this is actually a piece of art. What a lot of people that are familiar with me might know is I'm actually a resident at an artist studio here down in the southwest of England. It's a studio that is basically plays at the edge of live performance, installations, digital and technology. So there's, as well as the sort of art people there's a lot of technologists. There's a lot of people from the sciences, so people from the university and the UK's Met Office, which is based down here in Exeter. So it's a sort of weird mix between artists and technologists, and a lot of interesting things come out of it. And this project came out of a conversation we were having around privacy online, and about how people don't really know what, you turn your phone on, you join in that Wi-Fi network, and they don't really know, what it does. It's like you get your web pages and you're happy, right? But you don't really understand what your phone is talking out to the wireless network and what can be found out about you. So it's actually part of an art project that is around privacy.
I have known you for a little while, and actually I never knew that you worked out of this art institute, so that's fun to learn. But let's start taking a look at some of the components that go into this project. Well, of course, we should take a moment to thank DigiKey, who makes this series possible. If you're not familiar with DigiKey, they are an American-based distributor of electronic components, and including all the components that you need to build this project, which we're going to talk about in just a moment. And if you look in the link in the description below, you can get a link straight to the full build of materials for this list, or at least all the electronic components that you need to build this thing. And so you can hit that and then get started building your own network detective. But again, looking at the components here, you're not one of the components. You're the creator of it. The start of this, of course, is the Raspberry Pi, and in particular, this is the Raspberry Pi 3. I'm guessing.
Yeah,
I'm guessing.
So I used the Pi 3. I use the Pi 3 because it's got its own inbound Wi-Fi, and the project actually uses two different Wi-Fi networks. So there's an external USB Wi-Fi adapter, and it uses the internal one.
Yeah. Here is the internal network antenna, if I'm pointing this out correctly with my finger here. And then we have, just your standard USB Wi-Fi dongle right here. And you do that because you have one USB connection or one Wi-Fi connection for standard connectivity to the Pi, which is how we're going to be working with it today, headlessly, and then the other one is the one that is dedicated to monitoring the network, correct?
Yeah, so actually, basically the project's split down the middle. It uses one of the Wi-Fi adapters, the offboard USB adapter, to do in monitoring mode. Now, monitor mode is a lot like promiscuous mode, which people might be more familiar with for a Wi-Fi adapter, in which you can monitor all the traffic received on, over the Wi-Fi network. But unlike promiscuous mode, it means it doesn't actually have to be joined to that particular network to monitor the traffic. So effectively what it's doing there is it can see all of the Wi-Fi networks that the Wi-Fi adapter can see, and it can look at the traffic going back and forth. If it's an encrypted network, it can't de-encrypt the traffic, although that is possible in some circumstances, but it can monitor it, and then you can actually build up a profile of what's going on over the network just by the packet types that are flowing over the network.
Yeah.
The other Wi-Fi adapter, the onboard one, will be used in promiscuous mode, which is, so it will just be looking at the individual network that we want to monitor.
I do hope that, and the folks that are watching this in chat was able to grasp most of that. A lot of that went over my head because I'm not that robust of a network admin or security expert.
I served my time as a sysadmin, so I now have an awful fear of crawl spaces and cable pulls.
Yeah, well, I've done a fair amount of that myself, but I'm much closer to the edge of the spectrum of I plug my device in and get my web pages. A little bit more advanced than that, but not much. And also, if you are in the chat and you do have a question either for me or for Alistair, please ask them and we will get to them as best we can. But let's get back to the parts that are going into this. Get my switcher back here. And we also have to help drive the LED display. This is the SparkFun Red board. It's quite similar to the Arduino Uno. A couple other minor differences here. A USB mini port instead of the standard larger USB port.
You can use an Uno just fine, or pretty much any other Arduino clone. I just happen to use a SparkFun board because I had one on my desk.
Okay, and they're a little bit cheaper than an Uno. And then the aforementioned, I think you got to pull the camera back a little bit to show these things off.
Now these are absolutely awesome. This is a what is it? A 6-inch high 7-segment display.
I think they're a full. I think the product listing said 6.5.
Yeah.
But yeah, well.
Yeah, 6.5. You're right.
I didn't bring a banana, so SparkFun Red
Put
board.
the Raspberry Pi next to it. Everyone knows what size
Yeah,
Raspberry
Pi for scale. You get
Yeah.
that? Yeah, these things are massive, and we have 2 of them. So is it easy to extend the code if you have a large network and needed a 3-digit display?
It's very easy. These are chainable. I'm not quite sure how far you can chain them. I never actually had to look. The network at the Artist Studio, there's not many people at the Artist Studio, so that's fine. And obviously for a normal Wi-Fi network, for some normal home network, you don't need more than 3 of them because 256 is probably the edge of your DHCP allocation window. But yeah, you should be able to chain them quite a lot, I think. I mean, they're really quite cool devices, the way they work out, and the code is pretty simple.
And the last part that we need is just these large digit drivers that are also sold by SparkFun. These just pretty much solder directly onto the back of the display, like you see here, if I could focus. And yeah, so we'll be soldering those on a little bit later on. But we have
you can use the digits without the driver displays, in fact, but the driver boards make everything a whole bunch easier.
Excellent. Well, and I have done, this project does involve, as many Raspberry Pi projects do, does involve a little bit of installing a bunch of packages and updating and things like that. I've taken the liberty of doing a bunch of that ahead of time, just because there's a lot of little fiddly setup for it and some lengthy compiles, and that would just have us be staring at console windows a lot longer than I really would like to in this show. So I've taken care of a lot of that in advance. But if you do want to check out the full written instructions, go into the description and check the link for Alistair's full instructions on how to build this project. But we're going to be coming in right about the point that we are configuring. What are we configuring at this point? This would be, so I shuffle some papers around, and setting up the network scanner. going to jump over to my console here and sign
Still
into the...
scrolling. Are we configuring the wireless adapters? Was that the subhead I should be looking at?
This is scan setup.
Scan the setup. Interesting.
So the first thing that we need to do is install Nmap and ARPScan.
Ah, okay, we're there. Right. So, Nmap is probably the most common network analysis tool. It's used for network discovery and security auditing. And it's a very commonly used tool by system administrators or anyone that is sort of poking around on their network. Effectively, what you can do is you can go out and you can find what hosts are on the local network. You can do port scans against all of those hosts, although I will quickly add that, if it's not your network, you shouldn't be doing port scans on it. And you can do port scans and find out the open ports on those hosts and what services they offer and that sort of stuff. Basically, if you've lost your Raspberry Pi on your home network, Nmap is your friend.
Excellent. Yeah, that's usually what I use. Again, anytime I have a Raspberry Pi in my network and it's got a new DHCP lease, I just use a aforementioned app on my phone called Fing, spelled F-I-N-G, and it just does a quick network scan and usually finds...
My guess is it uses the Nmap library under the hood, like most of those do.
You are probably right.
Yeah. So the other thing you're installing is ARPScan. So ARP is the Address Resolution Protocol. It's specified by Internet Protocol RFC 826. So this is the thing that maps between the hardware address, the MAC address of your laptop or your dongle or your widget or whatever it is that is on the network, and the actual IP address that's been allocated to it by your router. Now, lots of things on a network won't respond to an Nmap scan. They won't respond to port mapping. If you have a Mac, for instance, there's actually an option to go silent on the firewall, as in don't reply to ping packets and that sort of stuff. ARP scans, and this is one of the reasons why we use ARPScan for this project. ARPScan you pretty much have to reply to, because that's effectively something on the network asking, hey, who out there has this IP address? In possibly thinking about, can I allocate this IP address? So effectively, even things that are trying to be stealthy usually, not always, but usually reply to ARP scans. And the ARP scan tool is a really quite nice little command line tool to do ARP scans on a network. And again, if it's not your network, don't do ARP scans.
Yeah, and it seems like the one that you get straight out of apt-get has an older version of this vendor list of the MAC address table. Then we need to get a new version of that.
Well, I think it's actually I don't think it's an older version. I think it's by default. The vendor list is not a distributable thing.
Oh, okay. I didn't even bother looking what's in this original Mac vendor text. I just moved over to the original.
Not very much.
And then
what I've done is I've actually snagged the Mac vendor list from another application, and done a bunch of command line hackery and a couple of Perl scripts, and beat it into submission from one format into another, and then uploaded it as a GIST. I think it's as a GIST, or it could be on Pastebin or something like that. And anyway, there's a link in the description. So this effectively is a mapping between. So it's basically, if everyone knows what the MAC address is for the hardware, the MEC address is the unique identity of the piece to the network adapter. And the first few digits of these hardware adapters tell you who the manufacturer is. So it's Apple or Nokia or whoever, or Samsung or whoever. So effectively, you can build a table to tell you who this device is from. And then for things like Apple, they use a subset of MAC addresses for iPhones and a subset of addresses for laptops. So you can actually go ahead and tell, hey, this is a phone, this is a laptop. And you can actually get a bit more resolution on that.
And now we're moving on to installing a couple of additional packages like DNS utils and the Perl stuff, or maybe some additional Perl extensions that make this project go.
Yeah. So this is like I'm looking down. So this is so you've copied the Mac vendor list in.
Yes.
Yeah. So we're in counting devices. So what we're installing now are some DNS utilities that the ARP-Scan tool needs, and a bunch of SQLite stuff. So the project logs all of the stuff and things that it actually logs to an SQLite database that it saves in the Pi's home directory. And what Tal is installing now is just a bunch of stuff that lets it do that.
And I'm just glancing over at chat right now, and Jordan Mann is asking, how often does Make stream? And right now we are doing a broadcast at least once a month. We do this as an ongoing streaming series with DigiKey, where we build stuff live right here on YouTube and on Facebook. And beyond that, we also do a stream on our other channel, on the Kids Make channel, and every week, as part of our Maker Camp summer education program. But unfortunately, our last stream in that series for this year will be tomorrow. But that's going to be happening at 4 p.m. Pacific on the Kids Make channel, which is a part of our channel as well. So anyways, thank you for watching, Jordan. So a couple other things to add in here. And this one is a very long one. Let's see if I get this typed in correctly the first time.
Yeah, so as you mentioned, we're using Perl for this. Now, this got posted on Reddit a few hours ago, and the main question that we were getting is, why on earth are you using Perl for this?
We had a little bit of a chat about that before we got started. I was having a chuckle about it because when last I would have considered myself a programmer by profession, Perl was a program I was writing in, and that was a long time ago. And I also was saying that Perl is the language that made me love programming, and it also turned me into a terrible programmer.
Yeah, so there's two ways to write Perl, which is the way 95% of the world writes Perl, which is write only, read never. You're basically using it to hack out a solution, and it's used extensively by sysadmins to do a lot of things. So there's a lot of tools in the Perl libraries, the CPAN repository, which deal with networking, because it's one of the tools used extensively by sysadmins even today. I have written millions of lines of Perl in my day. I used to be a very big Perl guy. And it's still one of my go-tos for fixing problems that I want to fix quickly. If I can't be bothered to build something that is going to be basically, this was not a project I was going to distribute. This was a project built as a piece of art, as the electronics side of a piece of art that was going to sit there and have big glowing letters and talk about trigger a discussion of privacy. So I put it together in Perl because it was really easy to do. And there's a few things that I would do differently if I knew from the start that it was going to get distributed and like a whole bunch of people would be watching you live build the thing on
No pressure.
So for instance, we haven't got there yet, but the script actually, what it does is it opens a serial connection to the Arduino clone and sends some data down and updates the glowing letters to tell you how many devices it is. It opens the connection right at the start of the script. Then it goes off and looks at the network, and then it finally pushes the final number to the glowing digits at the end. This isn't the best idea, because what happens is that, of course, when you open the serial connection, the Arduino reboots, and the letters shimmer, and then absolutely nothing happens because the same number gets retained.
Yeah.
And then a bit later it gets updated. So what really should happen is there should be two scripts here. One that does the network scanning, writes all the stuff to the database, and then another that fires up periodically and queries the database and asks what the latest thing is, and then pushes that to the Arduino. So I'll leave that as an exercise to the reader.
Oops. There's my first typo of the show. That's not going to resolve to anything. Typing in the bit.ly address for your Perl script. And you have that master the bit.ly short URL.
Yes.
Where have I gone wrong there? Oh, there we go. That's how you do it. Okay, and now I need to rename this to what it's actually going to be called. And the other significant component that I have set up on this Raspberry Pi beforehand is a package called Kismet. What does that do?
So this is, we're not going to be actually dealing with it tonight. Kismet is so basically the stuff we're doing tonight with the Perl script is all ARP scan stuff done on the internal Wi-Fi adapter of the Raspberry Pi. The Kismet stuff, which you can read about in the, am I above the link? Can I point down the link below?
Yeah, you are above the link. The link is in the description.
So if you go to the link below, if you read the instructions through, you'll find a bunch of stuff that deals with the other adapter that we're not really going to play with tonight, which is the external USB adapter. So that's this. So the thing that we play with on that is something called Kismet. Now, Kismet is a network packet sniffer. So basically, what it can do is it can actually go and look around the packets and see exactly what sort of packets are being sent. It works on the monitoring mode, so it can see what type of packets are being sent and the different types of the different networks that are around you. You can actually build up a profile of like what frequency the networks are on, where the traffic is, what time of traffic it is. So even if you can't read the packets because they're encrypted, you can do a lot through inference analysis. You can tell, when is the network used, for instance? How strong is it? You can get a reference to it. So you can imagine, although again, if it's like, no, your networks, you shouldn't be doing this stuff. You can imagine setting up multiple ones of these around it and triangulating signal strength and figuring out where networks are, which is sort of the reverse of how your iPhone figures out where it is in the world, because it's looking at the signal strength of the Wi-Fi networks around it. And you can do the reverse of that by setting up multiple of these and looking at the signal strengths at each Wi-Fi node. And Kismet is something that would let you do that.
So I've just run from the command line the counter.pl script. And you can see, fortunately, right above the bottom banner, if you're looking in the live stream there, it says samples equals 37. So that is that's the number of devices currently on our network right now, which we're actually having a big event today up in our other office for Make Magazine up in Sebastopol. So we don't have that many people here today. So that's actually a pretty low number for this office. Average is around 44, 45. But that's the number of nodes on our network here.
So you can see, like any good Perl script, there's a whole bunch of text being spewed out of it. It's like I spent too many years as a sysadmin. All of my Perl scripts use print to debug it quite extensively. So right at the bottom there, you'll have an average, which is has a date and the number of samples, which is the average number of devices it detected today. I don't know how many times you've run this one on this particular Pi today, Tyler?
First time.
Okay, first time. So that is, in fact, the number of devices it detected right in the scan.
Yep.
Above that, you'll see something like says CSV that has a whole bunch of bytes next to it, which is the MAC addresses of the 37 things it found on the network. These are effectively the devices, the physical hardware addresses of the devices it found.
Yeah.
And scrolling up beyond that would be the association between the IP addresses and the MAC addresses.
Yeah. So
if you run it again, but at the end put a minus dig at the end instead of just how you ran it there.
Yeah.
It'll do something else.
You said minus. What was that?
D-I-G. So all the command line stuff you put on it before, and then a minus minus dig at the end.
Okay. Well, I didn't write it out to the database file, so there's that.
What are you seeing?
Oh, I just did sudo counter pl minus minus dig. I didn't do the network home or anything like that.
Oh, yeah, I have no idea what it'll do in that case. It will probably create a... Yeah, I have no idea what it'll do in that case.
Okay, well, it's quite slow. You can cancel that.
Yeah, it's going to be very, very slow. It's doing something much more involved here. What it's doing is it's actually going through and asking each of the hosts it finds what its MDNS advertising name is. So you know how in your MacBook you've got a little thing that says, hey, this is Tyler's MacBook. In the network tab in settings.
Yeah.
Whatever it says. That'll actually be advertised on the Wi-Fi network as Tyler's MacBook.local. So what it's doing here is the thing that says desk is actually the MDNS, reverse DNS name of that particular thing. So so what you're actually seeing is that's the name it's advertising. Oh yeah, okay. So you're not actually seeing this. I've got you on delay here, so I can just see it coming up now.
Yeah, and I'm actually going to jump ahead to the next step we need to do here, which is we need to add running of the script to crontab so that we can have this run regularly. Yeah.
So what you're doing here is effectively you're just making it run in the background every 30 minutes or so, and each time it runs, so long as you put the correct command line flag in, which you didn't do last time, it'll actually write to the same database file, and you can build up a record of how things go over time. And what it's doing is it's actually building four database tables. So there'll be a first table named scan, and that records the time each time it's been run, and the host presence for each scan, so the MAC addresses it's found every time it scans. Then it will create another table called MACs, and that will record the number of times each of the unique MAC addresses has appeared in the scan. So, if your laptop's been in the network, every time it scans, then that number will start cranking up.
All right, so I'm in crontab now. And I believe the way you have this running by default is that it runs a scan every 30 minutes.
Yeah.
And I'm hoping I can get a little bit more interactivity than that, so that maybe I can take one of these devices off the network and we could see the number change or something like that. Although I think I left my phone.
Yeah, you just have to time how long it takes and make sure it doesn't trigger twice at the same time. So just crank it down to like 1 or 2 minutes. It should be fine.
Let's go with 2. Let's be a little bit hesitant, but I think the script really only takes like 30 seconds to run.
So I'm instead of watching in delay, I don't know whether you've still got network home in.
Yeah.
But that's your database name, whatever it is. It's
right. That's just an abstracted name of that's where it dumps the network scan information to a database.
Yeah, so it's not that won't affect the network it's scanning, because it will scan whatever network the Raspberry Pi is actually on at the time.
All right, so we save that, and now we just need to make a slight modification to our good friend that makes sure this stuff launches at boot, which is RC local.
Yeah, so there's 2 other tables, which is days, records the number of hosts on each scan for the individual days, while saving a sort of running average of the connected to devices. So you've got one table that says which MAC addresses, which devices were present for each scan. Another table that sort of says how many times this MAC address has been found. A third table that says how many devices we found in each scan, and then the last table is an MDNS table which maps between these MAC addresses and the human readable names, which is with the dig flag that we played around with a second ago. So yeah, editing RC local this is the thing that will get called when the Pi is booted. And the two things are in here, which is starting the Kismet server, which we're not really using right now. I think it's actually commented out in a couple of places in the instructions, because you don't, if you're not using it, there's no real point in running it.
Yeah.
And the mode I've got it in the installation is just using the ARPScan stuff. So I think that's why it's commented out in the instructions.
Yeah.
And then you start up the counter. The reason it's run from the root cron tab is that, of course, putting a Wi-Fi adapter into promiscuous mode needs root privileges. So I could do a whole things where I sudo enable the binary and a whole bunch of other stuff, but I couldn't be bothered because I didn't think anyone else would see this. So I just run it as root. Don't do that. It's not good.
And actually, I don't know where it is in our publishing cycle. We're actually done with everything we're working on with the Raspberry Pi, but we are putting together a pretty extensive article on how to secure your Raspberry Pi for any projects you're going to work on with it, because, well, I mean, we've heard countless things of botnets and DDoS attacks, and Raspberry Pis, particularly ones that are out there with the default and password with the default root password of Raspberry out there, are pretty vulnerable to some to things like that. So at the very least, there's a lot of stuff that that article is really extensive. It's really useful. But fortunately, the most important step is also the easiest. Just change that default password. I haven't done that here, so don't take my advice. But actually do take my advice and go do that. I'm not taking my advice. But I think the next thing we should do is we should get to doing some fun stuff, some soldering, and get these controller boards attached to these 7-segment displays. Because like I said, our work in the Raspberry Pi is done. I've got it rebooted. And although I suppose I should have checked to make sure that everything is running normally, but we'll debug that later if anything is.
Play it by ear.
Yeah. I've been over this a few times, and I know what to look for if I continue the mistakes I've made in the past. But all right, let's get these displays out there. I've got my soldering iron heating up. Crinkling of much anti-stat paper. And I'll start with this one first. And I need these controller boards, and the very first thing I need to do is I need to put a little bit of electrical tape onto the back here, just to protect, because there's a few traces and connections back here, and we don't want those shorting out in places where they should not be shorting out. And I believe SparkFun is, well, somebody's got to sell 7-segment displays of this size elsewhere, but SparkFun is
I gotta presume so. I just I found them on SparkFun, so that's where I got them from. It's
I kept
Google
looking in plenty of other places like DigiKey and
I would be very surprised if DigiKey don't stock something very similar.
yeah, I would have thought that maybe Adafruit would have, but
No, I don't. Adafruit don't have anything of this size.
they do not. That is a bigger solder blob than the one I did in my test build. Those are going to be, it's going to be a little bit tight there. Well, if only I had a tool that would help melt solder. I'm just trying to move, see if I can get this guy to melt and give me a little bit more clearance here.
So this is becoming fairly common these days. This is a castellated board, so called because of the way the contacts sort of vaguely look like. Is it embrasures? No, what is it called? The things on top of castles that you fire things through.
I always, when I was a kid and didn't really know anything about castles, but thought they looked cool and made good Lego sets, I always thought those were embattlements? Turrets? No, turrets are specifically the round things.
The turrets, the big sort of round building-y bits. The bit at the top, like the bit where it goes up and down. I can't remember what they're called. Starts with an E. Definitely starts with an E. But yeah, so there's a really good guide, and I put a link in, I think, from the instructions on the SparkFun site on how to solder these encapsulated boards. It's pretty simple. But there's slightly different technique than normal through-hole soldering.
Yeah, I didn't read that instruction. I apologize to you, but what I'm doing is just like you do with just about any other join, just kind of let it flow between the 2 points there, like I've done. Kind of start a blob up on the top part, and I really wanted to do that just because I probably still can move. I guess I can't. That one solder did tack it down, but start at the top here and let the solder kind of flow down and help guide it down with the tip of the soldering iron there.
Yeah, it's the important thing is to get it tacked down as soon as possible and make sure you got lots of tape before you get it tacked down.
Yeah. It's almost like basic welding. Get the camera in here a little bit closer. Focus it in there. Okay, that's a little bit of a clear view. And then we just go through all these other traces here.
So as I said before, you can actually you can use these displays without this driver board, but the driver board is really, really nice. It's essentially it lets you chain them together, which we talked about. So that's it's a really cool thing.
And we will be doing we will be doing that, 2 of these together. That's what I was trying to say. All right, that's everything on the bottom row stuck down. I'm going to lift this tape up and get these last 2 traces. These say NC, and I notice that they are also connected to this big 12-volt rail. Are these just additional structural solders?
I believe that's the ground pin, isn't it?
Well, that wouldn't make a very good ground because they're also connected to the same big fat trace at the...
Oh, yeah, okay. Yeah,
that 12 volt is on.
Yeah, I think it must be structural then. I remember doing this now. It's a while ago. I think it's structural.
I mean, that would make sense because this is, what's going to help hold it down on the other side of the board.
Yeah, if you go back to the instructions, it's like there's a huge big blob of solder across the top on the front side, so it's entirely structural just to hold it in place.
Who reads instructions? Okay, that's one of those. That's one of those done. Let's get the other. My other controller. Get some electrical tape on it.
Yep, I can confirm. I actually just did the instructions. They're for mechanical support.
Excellent. Trim off my excess here.
So one of the other things that came up on the Reddit today was the fact that a Pi was massively overspec'd for doing what we're doing, which is very true. You could build something that does ARP scanning on something like an ESP8266, or something, much, a microcontroller rather than a full-blown Linux a single board computer.
Yeah.
Um,
Although the nice thing about having a Raspberry Pi set up to do a relatively simple task is you can also have it do plenty of other simple tasks.
Sure. So, for instance, one of the other projects I did for Make, a couple of years ago now, was a broadband monitor, a sort of speed test thing.
Yeah.
And if you're building this yourself, you could run that on this the same way. So you could have something that's sitting there looking at your network, looking at the health of your network, and making sure that, as well as the number of devices about right, it's like the devices are the right devices. It's also testing the broadband speed. So I actually have this at home. I have a Raspberry Pi that sits there and looks at my broadband speed. It tests the speed of the network every half hour or so. And 4 or 5 consistent bad readings in a row, what it'll do is actually automatically file a trouble ticket with my ISP. It'll go to the web interface for my ISP, which I reverse engineered, and file a trouble ticket to say, hey, the broadband speed has dropped. Funnily enough, my ISP doesn't like me very much. Because as we all know, broadband speed drops a lot. Which is why I built the thing in the first place.
Yeah, similarly, I have a Raspberry Pi at home that I have Octoprint running on as a 3D printer print server. And that's a lovely piece of software. But also, again, when it's not 3D printing, it's not really doing very much. So I also have a pretty classic project of using the Google Cloud Print redirector so that I can, I have a fairly old printer. It is not Google Cloud Print enabled, but that just makes it easier for printing around the house from devices like iPads or things like that. Also, again, with it being a fairly old printer, it's not very well supported under Windows 10, which is what most of the computers in my house run on. So that also kind of helps simplify that as well. Okay, so these two things are soldered together. Wonderful. And now we can actually start chaining them together. Pull this camera back so we can get a little bit of a wider view.
So, of course, we're going to use jumper wires to do this.
Yeah.
Right now, if you know me, Tyler, you will be unsurprised to know that in the real production one, in the art piece, I still use jumper wires. I've just super glued them in place.
Well, that's one way to do it. I have YouTube commenters have learned me well that the only way to really do this is to solder them for a permanent connection. So that's how I do things. But again, for something quick and easy like this, we're just going to use jumpers like you mentioned. So
you saw the script running earlier where it just scanned the network, it looked for stuff and things. What it's going to do is that effectively, when it finishes the script, the number it pokes out at the bottom is actually going to send down to the Arduino clone, and the Arduino clone is just going to be sitting there with a sketch on it, which presumably we'll see in a bit. And the sketch will just be sitting there waiting for some input on the serial line. And it'll just take that, and then it'll be expecting a number, and it'll just push the number directly up to the display.
Now, I already have the sketch already running on the red board. Well, it's not running because the red board is not powered yet. But it's already on there, but we can take a quick look at the sketch and maybe just for fun load a new version of it on there. I am being pretty indiscriminate about my jumper wire colors because I am really just connecting these two boards end to end. Normally I would make some colors make a little bit more sense. Ground is black or white, and
Yeah, my OCD is wincing the fact that you haven't made the black wire be ground.
Well, part of the problem is I don't have a black wire. I have a gray wire.
You don't have a black wire?
No.
How can you not have black and red wires? Black and red wires, I have problems finding things that aren't black and red wires.
I really had to dig around to find these female-to-female jumpers. In fact, I had to take a big ribbon jumper and peel them apart. So that's why the colors are a little bit bonkers there. But these are really just lining up these two end to end, because they all stack the same top to bottom. So as long as you keep everything in order, it won't make yourself too crazy.
About a year or so ago, I finally sort of broke down and bought a whole bunch of female to female, female to male, male to male. I had male to male. Everyone has male to male. Big pile of male to male jumpers. But I finally broke down and bought female to male and female to female because they're just so handy.
That sounds like a reasonable and well planned thing to do.
Yeah, because otherwise you have to solder the little jumper bit like the header blocks onto the end of the. So I spent a whole bunch of time with jumper wires, like building up, wiring harnesses where I soldered various jumper wires onto the end of header blocks, and because it's just a simple way to build a wiring harness. And the amount of time you melt the plastic on the header blocks is just so annoying. I finally gave up and bought real jumper wires.
Yeah. Well, hopefully this will make you a little bit less crazy, because now we're going to pay attention to the wiring a little bit more. Although I still don't have a black wire for ground. I'm going to use a white one because even when I got my first Arduino kit and got that massive pile of male-to-male jumpers, I didn't have any black wires, so I just said, okay, well, I don't have any black. That means white is ground. And that's just the nomenclature I adopted for myself early on. Okay, where does lat goes to pin 7. We will not use the red wire for that. We have 2 red wires. Well, we will still use this blue one for lat. Oh, I made a mistake there. 5 is to lat. Seven to SER, which I assume means serial, and that connects to 7.
Yeah, the ground wire goes to ground on the Arduino. The lat goes to pin 5. The clock goes to pin 6, and the serial goes to pin 7.
The clock is what I'm connecting now. Would be if I hadn't missed the jumper rail here. There we go. And then we're going to have 2 red ones side by side because we're going to have 5 volts to, unsurprisingly, to 5 volts.
So the display drivers themselves are actually run by 12 volts. So you need a 12-volt supply to run the big displays, and of course the board itself runs from 5 volts.
Yeah.
This is one of the reasons. This is one of the reasons why we picked an Uno-like thing, because we can run that from a 12-volt supply and then pull up the 12-volt supply off the VIN pin on the breadboard.
Yep, and that is what we're doing now. And the next thing we need to do is we should get. Well, there's a sketch there, but I'm going to take a moment and make this a whole lot more visible. Let's go with the 28 font size. That's better. All right, let's take a look at the sketch here. Meanwhile, I can plug my computer into this and, well, no, we don't need to. We'll get that cable handy because we will need to connect it to the Raspberry Pi. But let's take a look at the sketch here really quick. Of course, we have really just this is where I wish you were able to see this in real time. Actually, let's jump over to Hugh. I think I can screen share this to you. Maybe?
Maybe. Yeah, for the chat, Tyler and I are video conferenced in, but I can't see what you guys are seeing. Well, I can see what you guys are seeing, but only at the same time you guys see it.
Oh,
All I can see is Tyler.
I need to add an extension to screen
Yeah,
show the
let's
screen.
not do that.
Yeah. Yeah, you're
So-
including this eprom.h library. And let's see if I can kind of interpret what's going on here. I don't know that I can. Not from a quick scan here.
So Tyler, I don't know whether you know, but we're both all of that stuff went directly to the stream.
Oh, yeah, I know.
Okay, that's fine.
Yeah.
Just in case you started typing passwords or something, you might want to go and change them now.
No, I don't think there was anything like that.
Okay.
Anyhow, so let's just get this thing. Well, as I mentioned, we already have this sketch set up on the board here.
Yeah, so effectively what this sketch does is it just sits there and it looks for input on the serial. And then what happens is it then just pushes this serial down through. So effectively saying they're expecting a number between sort of 0 and 99. And then it sort of takes that string and it pushes it through conversion. So it's effectively converting the number, the ASCII, the character into to which segments it should light up, effectively to display that character. And so there's a bit of code in there to figure out what segments need to be lit up for each ASCII character.
All right, so yeah, the sketch is already running on the breadboard. I'm about to, I've got the breadboard connected to the Raspberry Pi, and now I've got the board powered up, and I think we can take a look at these displays right now, just displaying the 00 here. If I crank this down, you can really see the red color there, but then everything else looks super dark. And now we need to jump back to our Raspberry Pi and do a little bit more setup to get the two things communicating here. All right, and the last few things we need to do, first we need to double check and make sure that we see the two devices.
So if you plug once the Arduino is plugged into the Raspberry Pi, it should show up as a serial device.
Yeah, so I just did the LSDev TTY asterisk, and then we see this very last one, the dev TTY USB 0. That should be it. And now we just need to get the install one more package.
Which is presumably the libdevice serial Perl package.
That's the one.
So if you were running the first script, remember to download the second script, which actually does talk to the Arduino.
So
if you run the other script.
Why did we download the other script first and then download this one? Is that just so we can test and verify everything's working?
Yeah, it's so effectively there's just a second version of the script so that the first one doesn't talk to anything on the network on the serial port, so that it just you can run it without big digits if you wanted to.
Oh, okay. No one wants that.
Well, you do want the big glowing digits, right?
We do. And I do need to jump back over to the instructions here because you didn't write this URL out in the instructions, or they're not written out.
I didn't. I just randomly linked it inline.
Yeah.
Oops.
And I cannot. I cannot actually copy and paste that from a piece of paper. That's one of the real limitations of paper.
Let me just quickly generate a Bitly link.
No, I got it here.
You got it?
Yep. All right, and all right, and then we're going to rename that to our good friend counter.pl. And we're going to make sure that counter.pl is executable or executable. And if everything, I'm going to go ahead and
So what I've just noticed is in the instructions we've published, the updated guest isn't actually linked from the instructions, so we need to fix that.
oh, we should do that. So we're going to run this script now again from the command line once again. And I'm going to go ahead and change the camera over to the 7-segment displays and make sure they're looking good. And
we have a moment of truth.
we do. And so it's still saying scanning. And it says 35 connected devices, and we see on the display here 35.
Yay!
We've probably done our job correctly, but we won't really know until this is the thing I was banging my head against last night, and with your expert help. Is this running on boot? So I'm going to do a sudo reboot, and now we see it goes back to the double-digit displays. Oh, it went to 88 there for a second, or at least full.
Yeah, it's so effectively when the script starts to run for the first time, when it opens the connection to the Arduino right at the start of the script, the Arduino will be rebooted. Now, what the Arduino does is it actually stores the last number of devices it was given in the EEPROM, and at that point it will put that back up when it turns itself back on again. But like just before it does that, it'll flicker to 88.
Yeah, but lo and behold, and you can see the full display here. We'd have it. We've done our job. We've built the thing. Although we haven't completely built the thing yet, because the last thing we need to do, because who wants to look at this display as it's sitting right here on this bench here? That looks ugly and gross. So fortunately, we have this enclosure left over from the build we did for the magazine that's already cut out the perfect holes for the numbers. So we're just going to stuff everything in here.
So is that laser cut? Do you have
this
files
is
for that?
This is intern cut.
Oh, I see.
Yeah.
Yes, automated by intern.
But I mean, it wasn't a tricky thing to do. I think all he did was just this is just foam core. What you see in here, that holes there,
Yep.
and he just laid out the numbers, maybe held them down with a little bit of adhesive, and then just traced around them and then cut through them with a craft knife.
Yeah.
No reason to make it super complicated. Even made these nice little inserts in here. Go to the numbers again. So we get the blacked out squares between the numbers, or in the gaps here.
So one of the things looking at the stream, one of the things the people in chat probably don't realize is how bright those displays are. They are blindingly bright.
Yeah, I mean, if
Not coming
I
across in the stream at all.
crank the aperture way down, you could see like how dark the rest of this here is, and that's where it's actually resolving to something that looks like red. Whereas otherwise, if I have this at normal brightness, you almost can't see them. They almost just completely wash out.
Yeah. Yeah, I had a bunch of problems taking pictures for this project, and I'm very thankful that we had Hep take it for the magazine.
Yeah, she. Well, you can see it as the banner image for the live stream. That's also that I stole that from the magazine production, but yeah.
Yeah, these are not the pale pink that you're seeing on the stream. These are blindingly red digits.
Now, if I can get all of this in here without unplugging anything, think about my order of operations here. And these, fortunately, just nicely press fit into the foam core here.
And this is generally where the jumper wires drop out.
Come on now. Okay, that one's in.
So if someone wants to do this themselves and use the foam core, how thick are the foam core are they using?
I meant to measure this because I was thinking I might even make a custom box for this. I think this is just a speaker box that somebody found at a flea market or something like that. I think this is like 1/4 inch or maybe 6 millimeter.
Yep.
And you can see here, well, let's, I need to get around to the other camera to lower its exposure. You can see there are 35 devices connected to this network here. And it's bright, it's easy to see, almost looks like, if you have an illuminated sign for like emergencies or exit or something like that, that's what it looks like. Only this is, here's the number of devices connected to your network. And that's going to do it for this show. Before I say goodbye, I'm going to reach back over to this camera here and raise the exposure again so it looks normal and doesn't look like I'm sitting here in the dark.
So this build's capable of a lot more than just displaying the number of devices on the network. But the way you do this to present it to the world is just, this is something that's doing something, right? So the big display here is like, this is a piece of technology that's counting something, that's counting the number of devices in the network. But you can do a lot more with the Pi inside this. The database that this device is building every time it does a network scan is a lot more than just a single number. And you can also go beyond that and do a bunch of other things.
Raise this up a little bit here. No, it's not terribly more visible. Oh, well. So once again, I want to thank everybody for joining us on this build today. I definitely want to thank Alistair, the author of this, for joining us. And if anybody has any final questions for Al, go ahead and drop those into the chat right now. But in the meantime, Alistair, any final thoughts on this one, or anything you would love to do differently if you knew were building this to be distributed?
Yeah, I don't know whether I mentioned it before, but the whole thing basically it opens the port to the Arduino right at the start of the script, and then the display will flicker as the Arduino reboots, and then the number doesn't change because it just pulls the number directly out of the EEPROM, and that's a bit disconcerting for people. The people don't know what's going on. So I would probably split this into 2 scripts. It would be one script that sits there and does the network scan, writes the stuff into the database, and another script that sits there and polls the database periodically and updates the display. So yeah, split this into 2 things. It really should be two different scripts.
Yeah. Although I will be honest, I actually really enjoy the shimmering display because I notice it seems to be doing that when it's actually scanning the network or when it's reiterating the display, and I like seeing that because it reminds me of like old, like flip displays or things like that, where it's just kind of flipping to the right.
The ones in train stations where they flip down.
Yeah. So it reminds me of like, okay, I'm searching for the right number. Okay, I've got it. I'm ready to display it for here. Which, of course, is not the way Simon Segment's displays work. But to me, it kind of emotes that same sort of thing. But anyhow, I definitely want to take another moment to thank DigiKey for making this series possible. Once again, if you look down in the links for the description of this video, you will find a shopping cart with all the parts that you need to build this project ready to go right there for you. And they're wonderful partners to work with to make this series possible. Once again, I want to thank Alistair for staying up very much past his bedtime to join us on the live stream here, and I also want to thank all of you for joining us and watching the stream. Once again, I want to mention that the final stream for Maker Camp, the Maker Campfire number 7, is happening tomorrow. That is going to be over on the Make Kids or Kids Make channel, which you can see is partnered with this one, and you can check that out tomorrow. Where we kind of wrap up what we've been doing. Maker Camp is our summer kids education program to introduce them into making. So they've been learning basic Arduino projects and other basic circuit projects and things like that, and also other crafting and sciencey projects and things like that. It's a really cool program. We're proud to be a part of it, and we're grateful to be able to present it every year. And of course, you can see the latest, well, it's kind of old now, the last issue of Make Magazine. That's Make Magazine issue number 58. But the magazine team has just sent 59 off to the presses. And that issue is about maker homes and home hacking and things like that. It's a really exciting issue. They're all tremendously proud of it. And if you are a subscriber, you're going to be seeing that very soon coming to your mailbox. And if you're not a subscriber, keep an eye out for that on your newsstand a week or two later. Beyond that, thank you very much for watching. If you're in the New York area, be on the lookout for tickets for New York Maker Faire. That's happening in the weekend of September 22nd through 24th. Al, will we see you there?
You will not, unfortunately. Nope. I can't make it in this year.
Worst Maker Faire ever. All right. Don't bother going. Don't bother going because you won't see Al there. But if you are in the area, please.
Probably go.
I should probably go. I think I'll end up going. And if you do, be sure to say hello and check out all the great stuff there. But beyond that, thank you very much for watching. And we will see you in September for the next episode of Make Live. Thanks for watching. Have a great day. Bye-bye.
Bye.
Now remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes.
Can I get a,
He'll take a Raspberry Pi 3.
No pie for you.
Told you. Hey, but I did hear this new deli. I can go pick up the sandwiches.
Don't be held hostage by the board holder. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.